Hi there, welcome to CERP TV and welcome to our calculus class today. Remember, at CERP TV, our mission is simple: to add something, to simply add something to what you already know. And our vision is to move the classroom right into your bedroom. Today, in our classroom, we are going to be studying more and more an introductory aspect to the rules of differentiation. Our last class talked about differentiation from the scratch, and today we are going to be studying the sum rule and the difference rule. This is CERP TV, and you are highly welcome. We will be right back. CERP TV. Welcome to CERP TV. Hello, welcome back. Now, when we talk about the sum rule, whenever you hear the word sum, what are we talking about? Addition. And whenever you hear the word difference, we are talking about subtraction. What are we saying? Consider that you have to differentiate with respect to x. Two functions, u plus v. That is two separate terms. It has two terms and there is an addition in between. What do? It simply becomes equal to, we have du by dx plus dv by dx. So whenever you have to differentiate a sum, all what you are going to do is to differentiate the terms separately. Okay, this is the sum rule. In other words, what if I was to differentiate with respect to x, and then let's say maybe I'm having something like two functions, f of x plus g sub x. What do? It simply becomes equal to f prime of x plus g prime of x. Simple. So, the question now is, we can also extend this to the difference rule, like if you were differentiating with respect to x, and then you have u minus v. U and v are themselves differentiable functions of x. They have to be differentiable for this rule to hold. So if we have to differentiate with respect to x, u minus v, it simply becomes du by dx minus dv by dx. In other words, if we were differentiating with respect to x, and then we have u minus, let's put in the form of function, with function notation, and then we have f of x minus g sub x those simply becomes equal to, like you're having f prime of x minus g prime of x. Voila. It's simple. So let me click here and try to explain what we are talking about. Now consider that you have been asked to differentiate with respect to x, and then you're having 2x minus 3x cubed plus x squared. What do? What these rules are simply saying is that you are going to come and differentiate this separately. You differentiate this one, you differentiate this one, and then when you have done differentiating them individually, you now add up. So let's go. We now have this being equal to, it's like I'm differentiating with respect to x, and then I have 2x then minus the derivative with respect to x. I have 3x squared plus the derivative with respect to x, and then I have x squared. Is that okay? So when I differentiate 2x, remember our last class we said whenever you differentiate ax, you simply get a. When you differentiate ax, you simply get a. So when I differentiate 2x, I simply get 2 minus 3x squared, the derivative of 3x squared. 2 comes and multiplies 3. We have 6. 2 minus 1 gives me 1. So at the end of the day, I simply have 6x. 2 minus 1 is simply 1. I don't have to, normally we don't write this 1, so I can clean it up. So I'm just left with 6x. Is that okay? Beautiful. Now, when I come to differentiate x squared, now when you differentiate x squared, you simply get 2x because this 2 comes down. Remember the rules of differentiation. Bring down your power, and when you have brought down this power, you simply subtract 1 from the same power. So we simply have 2x because 2 minus 1 is 1, and that's it. Okay. Sorry please, there is a little error. While writing this down, I made a mistake here. So can we correct it? This is 3x cubed, not squared please. This is cube. Okay, so maybe we can change our solution now. When you differentiate 3x cubed, 3 multiplies 3 to simply give you 9. So we simply have 9x. 3 minus 1 will simply give me 2. So we have 3x squared, then plus 2x for this one. So it's always good to go back and check your work and be sure what you have done is correct, because I'm allergic to errors. Thank you. Now we move on. So based on this knowledge, we have some problems to solve. And that's the problem we want to solve. Look at them here. We begin with number 1. Question number 1 says we should differentiate with respect to x, and then we have x plus 1 over x plus 2x. Let's put this in a bracket. So what we are basically going to do, we'll differentiate this, and then we'll go on and differentiate that other one. Is that okay? Now when you differentiate x, this simply becomes equal to, before we do that, I need to make an arrangement here. So it becomes equal to differentiation with respect to x, and then we have x plus, this will give me x to the power minus 1 plus 2x, because 1 over x is the same thing as x to the power minus 1. Is that okay? Beautiful. Now when you differentiate x, x is still the same thing like ax, because the a here is 1. So when you differentiate x, you simply get 1 plus, then you bring down minus 1 multiplied by x. Minus 1 gives me negative 2. So I have negative 2 here, plus, then here, you look at something, when you differentiate to x, what happens? You simply get 2. This is ax. Whenever you differentiate ax, you simply get a. Now 1 plus 2. What do I have? I have 3 minus, look at something here, x to the negative 2. So we simply have minus x to the negative 2, and which simply becomes 3 minus 1 all over, and then we have x to the power 2. Voila, so simple. So basically, keep the signs where they are and be differentiating the respective terms in what you have been given to do. Now we take on problem number 2. Problem number 2 says we should find the derivative. Number 2, that we should differentiate with respect to x, and then we are having x cubed minus square root of x plus 4. What do we do? This is very simple. It can be done. So we are going to differentiate this, and differentiate that, and that will be the end. So look at something, what we are going to do now. First of all, we recognize that square root, I need to see all the powers. So this will be equal to the derivative with respect to x, and then I have x cubed. Square root means x to the power half. Square root means to the power half. So I simply have minus x to the power 1 over 2, then plus 4. Now I can differentiate. Is that okay? So when I differentiate at this level, I'm simply going to get, when you differentiate x cubed, you bring down this 3 and subtract 1. So you simply have 3x squared. Minus, now I'm differentiating x to the power half. Now when you do that sort of thing, you simply get 1 all over 2x. Now half minus 1 will give me negative half. Half minus 1 gives me negative half. So I simply have negative half. This is a constant. 4 is a constant, no variable attached. So when I differentiate 4, I simply get 0. I don't need to do anything there, but for the purpose of clarity, we can simply add 0. Perfect. We are done with the differentiation. All what we need to do at this level is to arrange. We are going to arrange it to make it look beautiful. So this simply becomes equal to 3x squared minus, there is a negative half here that we can bring down. So we simply have minus 1 all over 2x to the power 1 over 2. There is a 0 here, of course. Anything, 0 added to anything does not change anything. Now power half simply means square root. So at the end of the day, I simply have this being equal to 3x squared minus 1 all over 2 square root of x. Voila. We are moving forward now. We look at question number 3. Question number 3. So we are today analyzing the sum rule and the difference rule. What we are saying essentially is that it doesn't matter how the question comes, respect the signs and do your differentiation. Now let's look at question number 3. Question number 3 says we should differentiate 4x squared minus 2x cubed divided by 2x. Is that okay? Now, please, this does not stand for anything. We need to make an adequate mathematical statement. It simply differentiate with respect to x, and then we put the whole of this here. I can go by the quotient rule, but because in this channel we have not handled the quotient rule, so we are going to stick to what we have done so far. We are going to simplify it and then use our sum rule or difference rule to evaluate. Is that okay? So this becomes equal to, it's like we are differentiating with respect to x, and then this one divided by this, I have 4x squared divided by 2x minus 2x cubed, which is this one, divided by 2x. Now this 2 cancels this 2, 4 cancels 2 here, so I simply have 2. This x is taken care of by one of the x's there, so this simply gives me 2x minus, what happens here? 2 cancels 2, and then what we're having here, x takes care of 1x here, so I'm simply having x squared. Now we differentiate. So I could have put that same bracket there. Now we have d by dx of this. And this simply becomes, when I differentiate ax, I simply get a. Here my a is 2, so I simply get 2 minus. Now when you differentiate x squared, you simply get 2x, because this 2 comes down and then 2 minus 1 gives me 1. So we simply have 2x. Now I'm going to do question number 4, and then you will have the responsibility to do number 5 and of course number 6. There we go. Okay, let's look at number 4. Number 4 says we should differentiate with respect to x, and then we are having 3 x minus the cube root of x plus 5x cubed. Voila. What do? This simply becomes equal to the derivative with respect to x. Then I open up a bracket. If I okay, let's rewrite everything. I have an arrangement to make here. Minus from the rules of indices, the cube root of x is simply x raised to the power 1 over 3. So we have minus x to the power 1 over 3 plus 5x cubed. So now what do we do at this juncture? We now differentiate. This becomes, when I differentiate 3x, I simply get 3 minus, I'm differentiating this, so I bring down 1 over 3, then I have x, 1 over 3 minus 1, then plus, this 3 comes down from our last class, we studied this, 3 multiplied 5 to give me 15, and then 3 minus 1 gives me 2. So all what I'm going to have here would be 15x all squared. But when I come here, this sort of thing can be very confusing. So 1 over 3 minus 1. Let's quickly evaluate it. Minus 1 over 1. LCM is what? 3. 3 divides 3 to give me 1. 1 times 1 is 1. So I have 1 minus 3 divides 1 is 3. 3 times that, we have 3. 1 minus 3. So I simply have negative 2 divided by 3. Perfect. So what do? Our final answer now becomes, so this is negative 2 over 3. So this simply becomes 3 minus 1 over 3. And then we have x raised to the power negative 2 over 3 plus 15x squared. That's the answer. So please, you have to try and do number 5 and number 6, and when you are done, let me know what your answers came out to be. You can leave an answer or a reply for me in the comment section below. Thank you so much for coming around and for tuning into CERP TV. Just in case you have not subscribed, please do well to subscribe right now. Do have a wonderful time. Bye-bye.